Okay, so in our last two videos, we learned how to find the mean and the mode and the average, and then we calculated standard deviation. And we found that player A has a lower standard deviation than player B, which means that his or her statistics are more bunched together and reliable. So what does that really mean? How does that allow us to find probability? Well, first of all, since these are more reliable, the shape of the curve would be more steep, meaning that most of the data will be bunched together and more accurate, while the shape of this normal curve that has a wider dispersion of data would be flatter. Okay, we call that skew, and we'll talk about that in subsequent videos. But how do we relate that to the standard normal distribution? Well, once we've standardized our statistics, which we've done already, they neatly fit in this any type of statistics. And remember, those are samples, right? It's not the population, it's the sample. They neatly fit into this standard normal distribution, where within 68% of the time, we should be within one standard deviation. So that would be 1 sigma. Within 95% or 95.4% of the time, our data should fall within 2 standard deviations, and within 99% of the time, we should fall within 99.7, 3 standard deviations. Now, the area under the curve will always be 100%, but as you keep going out further and further, the tail gets smaller and smaller, but it never really truly closes. So you could be 4 or 5 or 6 standard deviations, which would be like 1 in, many millions of probability, but you're still not ever closing the curve. So an event that's entirely improbable, like you hitting the lottery, the multi-billion-dollar lottery, would probably be 6 or 7 standard deviations if you put all these statistics for the lottery in a standard normal curve. So in this particular case, this player averaged 10 points a game, but at a standard deviation of, say, let's make it numbers easy, 4. So 10 would be the average, which would be mu. Plus 4 would mean 14. Minus 4 would be 6. So between 6 and 14 points, this player we would expect this player to score between 6 and 14 points 68% of the time. And if we double our deviation, which is say 8 points, well then 10 plus 8 is 18, and 10 minus 8 is 2. We would fall generally 95% of the time. We would be between 2 and 18 points. Now you can't go negative, and that's another conversation for another time, because the third standard deviation on the negative side will bring us into negative points, and we know players can't score negative points, but that also happens with the stock market. The stock can never trade below 0. We use a log normal distribution for those type of statistics, but here we're not going to concern ourselves with that. We just want to try to understand how these statistics fall within the standard normal curve. So that's how we relate. Once we standardize our data, then we can safely assume that it falls within a normal bell-shaped curve, and that within 1 standard deviation we have 68%, within 2 standard deviations we have 95%, within 3 standard deviations we have 99%. To go a little further, notice that this player had a 10-point average, but their deviation was 9. So once again, within 68% of the time, they should be 19 or 1. And then again, we run into that negative problem. But it gives you an idea of how statistics, if in this case with a player, they're not going to score negative points. But in a case where you can go negative, or where there's a wider dispersion of data, this would help you to understand how we look at the normal distribution. So notice these would be minus 3 standard deviations, minus 2, minus 1, plus 1, plus 2, plus 3 standard deviations. So to get something that's 3 standard deviations from the average is relatively remote. It's like a 1 in 100 chance. Hopefully that begins to explain how we fit things in a normal distribution. In my next video, I'm going to show you how to use a z-table in order to find exact probabilities.